fabrication and fusion of steel, iron, and other metals into products for commerce, transportation, and construction. Welding skills hold together our modern industrial society. In this volume of our series, we will examine gas metal and flux core arc welding systems, their design and basic operation. Throughout this program, important safety information will be highlighted. Safety first means stop and think safety before you undertake the next welding procedure. It's also important to always develop your welding skills under the watchful eye of an experienced teacher. There is no substitute for hands-on training. To prepare for gas metal and flux core arc welding, a student should wear the same type of heavy clothing required for most arc welding. All bare skin should be covered. Heavy gloves are necessary to protect against the intense arc generated. A welding helmet with a number 12 to number 14 filter lens is required. Safety glasses should be worn whenever chipping or examining metal. Inert gases such as argon, helium, and carbon dioxide are used in both the gas metal and flux core process. Both systems generate toxic fumes. Fumes should be collected and vented through a smoke and filter system at all times. Vent the work area with a fume collector if available. Gas metal arc welding is sometimes referred to as MIG welding. MIG and flux core arc machines are always of the DC or direct current type. They are designed to provide constant voltage. These machines are said to be self-adjusting as the voltage increases or decreases with the distance between the electrode wire and the weld pool. The electrode in both types of systems is fed from a wire feeder through a welding gun. The electrode wire is melted and becomes part of the weld. It is a consumable electrode. In MIG welding, the electrode wire and the weld pool are protected from the environment by an inert gas. The gas is supplied from a cylinder through a pressure regulator and flow meter. In flux core arc welding, the electrode wire is hollow and filled with flux. The melting flux creates the shielding gas necessary to protect the weld. Gas metal and flux core arc welding outfits are more complicated than either an oxyfuel or arc outfit. Power is provided through a ground lead and a lead attached to the welding gun. Hoses and a flow meter supply the shielding gas to the gun. The wire feeder holds the electrode wire. A set of parallel gears drives the electrode wire from the spool to the gun. The speed and tension of the feeder can be adjusted. Electrode wire is supplied in spools of several hundred feet. This is one advantage of MIG and flux core welding, as long continuous welds can be made without a break. Different types of electrode wire are available for welding different types of base metal. An inert gas cylinder of either argon, helium, or carbon dioxide attaches to the metal gas welding outfit. Use the proper procedure for moving and storing cylinders when installing or removing a cylinder. Never use a cylinder with a bad label. Always chain and store cylinders in a vertical position. Safety first. Always use caution and check the area before blowing a cylinder outlet clean. The regulator body attaches to the gas cylinder valve. Tank pressure is indicated by the regulator dial, and the amount of gas flowing to the gun is adjusted and indicated by the flow meter. Always read a ball-type flow meter at the top of the ball. Use the pre-flow switch on the machine to get the gas to flow for a short time. The flow can be adjusted on the machine. Safety first. Some flow meters have markings for more than one kind of shielding gas. Be sure you are reading the correct scale for the gas you are using. Setting up to weld with a gas metal or flux core arc welding outfit should be done methodically and in a given order. First, make a visual inspection of the machine, gun, wire feeder, gas cylinder, and all connections. They should be in good condition and show no visible signs of damage. Check gas connections with soapy water or a leak detecting solution if in doubt. Safety first. Never assume that the previous user left any type of welding outfit in a safe condition. Make your own inspection. Next, check the gun, which is trigger operated. Make sure the electrode wire is properly inserted. The electrode wire passes through a copper contact tube which must be sized for the electrode. Change the tube if necessary. The small hole in the contact tube can wear out and should be checked periodically. The American Welding Society classifications outline the types and kinds of electrode wire suitable for different base metals. Make sure that the adjustment valve on the flow meter is closed. Slowly open the cylinder valve all the way until it is back-seated. Consult the manufacturer's chart for correct flow rates for different base metals. In both MIG and flux core arc welding, the electrode must be adjusted before striking an arc. Use the inch switch or trigger to extend the electrode about a ½ inch. Check the manufacturer's chart for the correct length for your work and cut the electrode to that length with a pair of wire cutters. If you have followed the previous steps carefully, you are ready to start an arc. A welder should always alert others in the general vicinity where he or she is striking an arc. Watch your eyes is a good warning whenever you're starting to weld. Hold the gun at about a 20-degree angle from vertical in the backhand position. Position the electrode about 1/16 of an inch from the base metal and activate the gun trigger. The arc will form almost immediately. Once you have full current, move the gun steadily to establish a good weld pool. To shut down a MIG or flux core machine, first release the trigger on the gun. Close the flow meter adjustment valve completely. Then close the cylinder valve. Open the flow meter adjustment valve again and press the pre-flow switch. This should remove any remaining gas in the hoses. Turn the wire feeder off, then the power to the machine. A welding outfit should be left in good condition with the leads and hoses where they will not cause a hazard. Laying a bead with gas metal or flux core arc equipment is considered easier than in some other types of welding. The machine is self-adjusting and the wire is fed automatically. Very little slag is created and long, clean welds can be performed. Out-of-position welds can be made and are used for fabricating complicated weldments. As with all welding, practice and good technique are required to achieve good results with a MIG machine. Cold lap is a defect that develops when the filler metal is melted, but the base metal is not. Concentrate heat in the weld pool area until base metal penetration occurs. Porosity occurs when the flow of shielding gas does not protect the weld. Be sure that the correct flow rate is set and all connections are good. Gas metal and flux core arc welding is used in manufacturing and wherever high-quality, uninterrupted welds are desired. Metals like aluminum and stainless steel can be welded with good MIG and flux core technique. The quality of the MIG and flux core welds you are able to accomplish will depend on your ability and your understanding of the methods and practices of modern welding. With that ability, many career opportunities await you in manufacturing, industry, and construction where modern welding skills are essential.